Hello again, my name is Will Patillo, and today we will be completing our four-part series on moving, scaling, and rotating the Vive camera rig in Unity. So what we're trying to accomplish here is when the player presses both grip buttons on their controllers and moves their hands in a circle, then they turn on the y-axis like this, or the other way. We've already completed scaling the camera rig, getting bigger and smaller, on moving the camera rig by just pressing one grip button and pulling, and so this completes the set. So let's get right in. This entire video is going to be focused again on the rig control script. We already have everything set up from our first video on controller inputs. So I'm going to start out in this rotate rig function here, and start by, I need to get the angle between the two hands before I can use it to rotate. So no, correct. Angle y cur, let's call that variable, equals get hand angle, and I'm going to need to pass in to the positions of the left and right hand. So that is left hand lock dot position and right hand lock dot position. Okay, and I'll just create that function now to get rid of the error message. So get hand angle. Sorry, this is a float because it's passing back a floating point number. And we'll just call these vector 3 position 1 and vector 3 position 2. So I'm getting in these two positions and passing back a float, which can then be used to calculate the amount of rotation needed. Before we go into this, I'm just going to set up the rest of rotate rig, and this is, I'm not going to explain too much on this because it's going to work very similar to our scale rig and move rig methods. As usual, a little bit of initializing to prevent that error before it even comes up. So if angle y previous equals 0, then angle y previous equals angle y current. Just like before. Oh, and so I can get rid of those errors. I'll just declare these variables now. Angle y current, angle y previous, and angle y change. Okay. All right, so if this is the first frame where you're rotating the rig, then previous hasn't been set yet, so we can't figure out what the difference between them is. So just set the previous to the current on this frame, and then the next frame we can proceed as normal. So the rest is going to go into an else statement. And angle y change equals angle y previous minus angle y current. And next, transform dot Euler angles, and this transform, of course, refers to the camera rig itself, which this rig control script is attached. Euler angles plus equals new vector 3 0, because we're not changing x, angle y angle y change, and 0. So here we're going to determine how much the angle between the hands has changed since the last frame, and modify the transform of the camera rig by that amount on the y-axis only, leaving x and z as it is. Okay, and then finally, we're going to set the previous angle, so angle y previous equals angle y current. So if the next frame it's a different number, then we'll be able to compare them. Okay, that's really the basics for how this is going to work. So now let's look into getting this hand angle. First we need a new transform. Call this the midpoint. And actually I'm going to write some pseudocode here to clarify what our process is going to be, because this is kind of the trickiest part of this whole setup. So first we're going to place a midpoint between the player's hands. Then we're going to direct the midpoint towards one hand, doesn't matter which. And after that, we're going to find the normal, or that is the direction we actually want to face. So this is based on the idea that if you have, actually I'll bring this up in Paint. So if, say, you have one hand is over here and you have another hand is over here, these are the Vive controllers, excuse my drawing. If you take a midpoint and you aim it towards one of those controllers, then go at a 90-degree angle from that resulting line, this is the normal line, you will get the angle that you want to face. If this were to move down over here, goes like that, then the midpoint would be here, and the normal line would be facing that way, which again is how we want to face. And the resulting change would have been moving from here to over here, and then that's our rotation. I'll close that little visual aid down. So let's actually get this stuff. So midpoint dot position equals find midpoint, and I'll create another function just for this and come back to that. Then midpoint dot look at, and this is going to be, you could pick either one. I'm just going to go with position 2, so that's, I think it'd be my left hand, or it might be my right. Actually, I'll just go with 1. It doesn't matter. And vector 3 dot up, because the Unity's look at function, it takes one argument is the transform target, and then the other one is the axis that we're orienting on. So since we're rotating on the y-axis, we're going to orient it on the up line, or on the up axis, and target the hand. Let's see, lowercase. Okay, there we go. And then to get the normal, midpoint dot rotate 0f, 0, 90f, and 0. Keep those nice and centered. All right, that's the essence of that. Oh, and then finally, we need to actually return a value that this rotate rig can use. So return midpoint dot rotation dot y. Actually, no, that's not going to quite work because rotation by default is going to be in radians. So actually I should add in rotation dot Euler angles dot y. That way I'll get a number between 0 and 360 or something in degrees that I can actually use over here. I suppose we could make this just transform.rotation and this midpoint.rotation.y and just use radians all the way through, but that gets kind of confusing, so I prefer to stick with Euler angles as they're a little more user-friendly. Okay, semicolon there. All right. Now let's find that midpoint. Again, here we're going to return a vector 3. And I suppose this doesn't really need to be, because it can be a private function, so find midpoint, and we're going to need, oh, and this function is going to need the 2 points it's finding the midpoint between. So that's going to need a vector 3. I'm just going to call it 0.1 and vector 3, 0.2. All right, and now we need to actually pass those in. So I'll just give it pos 1 and pos 2. So just take the positions that get angle received and then just pass them right on to find midpoint. So it's really coming from over here. Left hand locked up position and right hand locked up position. Declare a vector 3 and I'm just going to call it m. And at the end of this, we're going to return m. Okay. Now m, actually I can just put this all on the same line here. M equals new vector 3. This could be a little bit lengthy. Right, so to get the midpoint between two locations, I'll start with just the x-axis and have P1 dot x minus P2 dot x, and all of this is going to be divided by 2, and then we'll add back T2 dot x. Right, let's see, got my brackets all lined up. Okay. We'll have a similar thing for y. Let's see, I don't. Same thing with y. And the same thing with z. Okay. And oh, also one thing that's gonna P1. I don't know, why is it giving me texture 2D? that right? No. No, these should be 2 plus p2.y and p2.x. Okay, make sure I got this all right before I go in and try to describe it. Okay, so it's been a while since I figured out this math. Let's see if I can remember it again. Let's bring out my notepad. Don't need that anymore. All right, so let's say we have our number line, and let's say here we have 0 over here, and we have one hand is there. Let's say this is at 3, and now we have another hand that's over here. Actually, this will be a good chance to check our work here, and it's at 5. Hopefully, the result of our calculation will be 4. And if so, that's good. So let's see if that works. So right now we have, so p1.x is going to be 3 minus p2 is 5. And this is all divided by 2, and then we're going to add 5. So that equals -2 over 2 plus 5, which equals -1 plus 5 equals 4. So yes, it works. And you could try that for other sets of numbers if you like, but I've already done this, so just either do that on your own or take it on faith. Oh, and one other thing that we should do here, just to make sure there aren't any errors, is gonna cast this whole setup to a float. So get a float and close this whole thing so that it applies to the whole calculation. All right, and that should be all we need for finding the midpoint. Now with the midpoint, we were able to get the angle between the hands. And then with the angle between the hands, we're able to see the change in angle between the hands and modify our camera rig accordingly. So there's a few more things I'm going to add for some error correction that's going to come up, but first I want to just see how this works right now. Press the grip buttons on each, move them around. Okay, the scaling's working, but I'm not seeing any rotation happening. What is going on? Oh, looks like we have a console error, so let's start with that. What do we got? Object reference not set to an instance of an object. Line 110. Okay, midpoint. Oh, because we haven't declared what this this transform is. So let me go back and set that. I think what I'm going to need to do here is just make this into a serialized field. Ah, yes. Then I'm going to, never mind what that object was, I'm just going to recreate it. It was already in place. Now I'm going to create a new empty game object. I'm going to call this midpoint. 0 at its position. And then on the camera rig, assign midpoint over here. So now what will happen is this midpoint game object will physically move around to a point in between the two controllers continuously whenever both grip buttons are pressed. And this is what will rotate to get our rotation. And that should clear that console error because it has to actually refer to a existing game object. Imagine there's ways that I could do this entirely in the script without assigning anything in the inspector, but this seems to work pretty well. Let's try this again. Alright, got my grip buttons, and yes, I am able to rotate. Oh, but there's a little bit of a problem. There's this kind of flickering effect where sometimes it's not so bad. And actually the first time I did this it was pretty clean, but sometimes it's just terrible. So I'm going to add a little bit of error correction to clean that up. So basically what's happening here is the exact tracking on the hands can be a little bit erratic, and since we're dealing with such small motions, again, since it's looking at the location every single frame, we sometimes jump back and forth between positive and negative numbers. So add something in to prevent that from being an issue. So let's see, in our rotate rig, go over here. So first I'm going to add a new variable called angle y change previous. So how we're going to prevent that jitter is we're going to look at the angle y change this frame, compare it to the change in the last frame, and if the number has flipped sign, then we'll ignore it for this time around. And that's not going to block you from turning back. You'll just miss one. If the player actually moves their hands in the opposite direction, then they'll just skip one frame, and then the frame after that it'll have been the same sign, so they'll be able to turn just fine, and missing a few frames in here and there is not going to affect the experience in any noticeable way. If angle y change previous equals 0, angle y change previous equals angle y change. That's basically the same thing that we're doing up here. Dealing with that first frame issue. Else, here's where we check if it's flipped signs. If angle y change times angle y change previous is less than 0, because if you multiply a negative times a positive, you get a negative, but a positive times a positive or a negative times a negative will both be positive. So this little bit of math right here always tells us whether it's flipped signs and is therefore a frame that maybe we should ignore. Then angle y change equals 0 and angle y change previous equals 0. So essentially just skip this. Oh, and one other thing that's happening, now that I think about it, we're noticing the biggest problem the second and third and so on occasions where I tried to rotate, but it wasn't really much of a problem at all the very first time. And I think that may be related to yes, this issue again. If you press the grip buttons in with one particular rotation, move them around, let go, then move your hands a little bit and press again, then that's and it's still storing where your hands were on the last frame that you had the grip buttons pressed, then when you press them again, there's going to be a huge delta there. So that's what causes that huge movement on the very start. So let's get rid of that by just adding one more line to our reset move, and angle y previous equals 0f. Alright, let's try that again. It's the grip buttons. Okay, this first turn is pretty smooth. I let go. Try it again. Once again, I'm able to rotate as I turn my hands. It moves at about the same speed that I am. I can move multiple times by doing this. I also have the same grip buttons to scale and to pull myself around. And so, yeah, and with that, we are finished with this series. You can now move, scale, and rotate the camera rig with a mechanic that's very similar to what you see in applications like Tilt Brush and other VR CAD modeling programs. You could also use it for games as well where applicable. So once again, as I've mentioned in these previous videos, if you had trouble following along, there was errors, or you just wanted to skip all the tutorials and just get the code, all of this is available as a project for free on a public repository on GitHub. I will link to the project in the description below this video. And if you like this video and you feel like you learned something from it, please don't forget to like and subscribe to this channel. If you'd like to help me out a bit more and see more content like this, then check out a copy of my first VR game, Will-O-Wisp VR. It's available on Steam for just $5, as well as a free demo version. Also, if you enjoyed following this project and would like to extend it a little bit, one challenge that I attempted with this but did not quite figure out, although it seemed like it would be something easy, is to be able to rotate on the x-axis. So what I mean by that is if I start this, I take my hands and I rotate, turn my hands like this way, then my head would rotate like this. It's not likely to be as useful for as many applications because that could be a bit disorienting, rotating in that way. But it would be interesting to be able to give the player full control over which direction they're facing, not just rotating around on the y-axis, but turning on the x as well. And for some reason, you would think that you just repeat the same code, but instead of y, you use x. However, there's a lot of problems that showed up. One was, from interference between different things. Which one is it looking at? There's also the issue that, because I guess maybe it's something to do with the math of quaternions. Rotating on the y is fairly straightforward, but going on other axes, at least in Unity, it doesn't behave the way you would expect. However, if someone else who's watching this would like a little bit of a challenge for extending this and can figure that out, please mention that in the comments and upload a change on the GitHub. I'd be happy to incorporate that and be interested to see how that problem gets solved. Otherwise, though, this series is finished, and so thank you very much for watching, and this is Will Patillo signing out.